Welcome. We start with company update.
Progress on the Xbox last week. I'm gonna get a shipping container probably this week.
Where are we going to put it?
Back.
Okay.
Yeah. We're gonna spray paint on the ground room for 2X.
Yeah.
The Xbox is also gonna have some batteries in it. So we can time shift power. Yeah. The price of 5090 is upsetting. We should have bought way more 5090s than they were cheap. But then there were actually two things to buy that were better than 5090s, like AMD stock. We could have just bought AMD stock, but then even better to buy than AMD stock was RAM. We could have bought RAM.
Or just my micro stuff.
Is that going up way?
Every time you want to buy the hardware, you can also buy the company that such
Sure,
hardware.
that's easier than stockpiling RAM. Yeah, that and chestnut progress. We have a lot of chestnuts now.
Oh, we launch this week?
Oh no.
Next week?
No.
Okay. Soonish.
Yeah, I mean, I don't know. Like, we could launch it and do like a pre-order whenever. I don't know. But no, it basically comes down to like what you want your margins to be. Like, you can trade off price for speed. And I told everyone to just make it cheap.
But how cheap is it?
Cheaper.
Okay.
We can go over what the real margins are, but no, yeah, you just end up paying like 30% more if you want it like soon.
I see.
For all sorts of various reasons. Yeah, I mean, you think that's worth it? I don't think we're in any rush to launch it.
I don't know. Okay. Anything you want to comment on the contributing policy you just added?
Oh yeah. I don't know. I mean, like the problem with like saying anything about it is like it's the people who don't listen in the first place. Every single open source project is going through this. I see these on Hacker News all the time, where it's just like we're just absolutely done dealing with AI. Please don't submit any PRs you don't understand. You're not helping. Uh, it's like I get it. I get it. Like AI so easily fools you into thinking you understand something. I don't know. Not everybody's gonna be robust to this. Like it's not even like these people are malicious or trying to like like pull one over on us. They genuinely think they understand and they just don't. So yeah, that's new policy. Please include a sentence or two about why you want the PR merged. And if you're submitting a PR you don't fully understand, haven't carefully read, to be banned from GitHub. Not everyone can help themselves with AI.
Let's move on to next one. Next is my change. So I changed all the div mod, almost all the div mods before late mixing now. I say almost because there's one place that if you just call the truncate, you will get the cdiv and cmod directly.
See, that'll violate the new spec.
Okay, I keep that for the same reason that we keep the shift left and shift right. Technically, you can also change that too, but we keep those.
Well, no, I'm not sure that's true, right? The problem with shift left is you actually can't express shift left as a multiply. You can only express shift left by a constant as a multiplier.
Sure. We don't use that. Even if you do a shift by const, its canonical form it has two forms, right?
Yeah, but
Okay, anyway, so,
yeah,
so I can make that change. It's just now our simplifier is not good enough to find that pattern, and I don't really know what that pattern look like. Basically, you want this to be represented in lower form, even if you want to truncate. But magically, after you write it back to the form, your correction term will cancel out. That's what we want. I don't have a good solution now, and that's why it's kept that way.
Yeah, I mean, I think that this is really what we want to like tighten with the spec.
Yeah.
The question is not, so if you think of TinyGrad as this big like hourglass style shape, right? There's like a lot of stuff in the front, a lot of stuff in the back. Then like when we're in this whole middle, when this whole like chunky middle, that's where we really want to check the spec. That's where we really want the spec to stay solidly simple. It's not that we need less ops. The ops can exist, whatever. By the time we get to like cogen, who cares? Who cares if there's like a sub op or something? But we just don't want these to ever show up when we're doing passes. And we need to start enforcing that.
Okay. Yeah, I'm fine with that. I just don't have a good way now because it's for the cases that in late rewrite you have more complicated stuff. Sometimes you don't want to simplify those expressions. For example, for the decomp for some of the sign, what was it called? Incidental thingy, sign log x. We really don't want any reorder for that because it's more stable the way we express it. But then we start to have this div into the lower div into the C div with a correction term. This time we wanted to cancel with a previous correction term. I don't have a clean solution for that. It's like maybe it's just it's not enough to have just one late rewrite. We need to clean that better. Anyway, that's it. Okay. This week I'll think about what to do with the rest of the tensor. I have some ideas, and I try like some of the stuff to remove things either into a rewrite rules or just see if I have ways to delete those. Two of the biggest thing is one is image. Image is a big chunk. Another is not 3 fry, sorry, the vinaigrette. I also tried the vinaigrette as a rewrite rules, which is pretty fun. I add from 3 to 3 to all the way to like 7 to 7 vinaigrette, and everything can be expressed in a nice way. Like you just add a few metrics and you would just match those and do the rewrites. I just need to think more if that's a good way to write it. I don't want to just move vinaigrette to mixing. Let's vinaigrette.
Yeah, it'd be really nice to have that as a rewrite rule. Also the image stuff as a rewrite rule. I mean, the image stuff is kind of a this all gets to this idea of like those are heuristic rewrite rules. Right? This gets idea of like we're overloading the rewrite engine to mean two things. There's the rewrite engine that are deterministic transformations from basically one dialect to another dialect. They're not exactly dialects. And it's a lot better than it being dialects because the problem with doing it with dialects is these things are no longer like reentrant. You can't like rerun it again. It's like, oh, well, I already lowered to that dialect. Sorry, like there's no way you can add a like you should be able to add permute to basically assembly code, and it should figure out what to do. If we do a good job with this, but we should still separate the concept of rewrite rules that change dialects versus rewrite rules that like Winograd or like image, which stay in the same dialect but apply some heuristic transformations in order to
Yes.
yeah.
I think that's what I meant maybe a year ago for the smallest set of rewrite rules that still generates output.
Yeah, like we're getting there, and actually, it's funny how we're getting there. We're getting there not through pruning of rewrite rules, but we're getting there by most of the rewrite rules just kind of like don't do anything anymore.
What do you mean by that?
Well, okay, so like take like if you run with no opt, most of the rewrite rules like barely trigger anymore. There used to be, think about all the stuff that used to like manipulate movement ops, right? They used to like move movement ops around and like, oh, you can like pass a reshape through a permute, you could collapse it into a view. All that stuff's gone.
Gone because there's a rewrite rule in Rectify that rewrites these.
There's one thing called indexing, and indexing actually, Rangerify's crap, but indexing is good. Indexing is like direct and pretty simple. The Yeah, no, I mean we'll replace it with this like concept instead of with like movement. So you can't remove the concept. Of course, the concept still has to run. It's a dialect transformation. Or take like linearizer. Like, think about what the linearizer is now versus what the linearizer used to be. The linearizer used to be this thing that would create these like end blocks and all of these like weird things. Now it's like it's a topo sort. So you're still going to need stuff like indexing and the linearizer. Those almost aren't rewrite rules. That's what I mean. All the rewrite rules that actually used to like change stuff
Okay.
are kind of gone. We've replaced it with these few deterministic like stages. So yeah, I mean to ask the question like what's the minimal rewrite rule? The answer is kind of like no rewrite rule. Like today, if you just do indexing and linearization, it's a program.
Anyway, let's move on. Next is this.
Yeah. So I had GPT 5.5 work on the e-kernels in Llama. I posted the weights and biases run in there. It like got it to fast, but as you see, like it doesn't even ever converge.
So
So
it broke it.
Yes, but like there's no way for me to actually give feedback to the agents that it's broken.
You know why? Like, what broke?
No, that's the problem, right? I think like there's two parts to this agentic loop. One part is like giving the agent tools to give itself feedback about what is changing and seeing the effects in the kernels. I think I did that last week, but now it's more about verifying that the changes are actually correct.
I mean, there are types of changes like you can just look at the change and know its equivalent. And there are other types that when you make a change, you know the behavior is not exactly the same, and sometimes you would know if it's prone to error. You know, like what kind of changing are we talking here? Because it would be very weird if you are telling me the agent find different ways to compile the code, the same code, and now it behaves differently, right?
Well, I mean, it probably just introduced a bug, right?
That's
That's
not
exactly. It introduced a
weird.
bug. The agent was trying to remove the e-kernels that were doing the copies.
Yeah, but it would also be weird that if we just remove some copies and now the behaviors are different. Because it's very hard for me to understand when you say agent did something and now it doesn't converge. And the natural question is, what did it change? And how can this,
Yeah.
what kind of behavior change are we talking here?
Yeah, I think that the answer to this problem is not like trying to build tools for it to check that it didn't break anything. I think the answer to this problem is just to constrain its search space to the way that it can't break things. Like there's safe transformations you can make to a graph, but I think that, well, we're already submitted for Llama. So I think that like let's not focus on Llama. Let's instead focus on, I think, gem kernels. Like I want to start seeing this yield kernels that are better than the best ones in the world.
You would have to go to assembly for that, right?
Well, that's fine. Yeah. I mean, are you sure we have to go to assembly?
Pretty sure.
Are you sure if we go to assembly, you would generate a kernel that's the fastest?
That's a different
I mean,
question.
I'm kind of
Because I would
Just
also
observe-
imagine other people try the same thing in assembling to start with.
AMD's highest performing kernels are assembly.
No, yeah, no, I mean, you're right. Yeah, the AMD ones kind of are. Yeah, I mean, okay, then maybe instead of that, focus on the like basically cleaning up that Quen speed up.
Exactly. I think that's what I'm going to do. Like more high level, schedule some amount of kernel that gets a reasonable performance with C at best.
Yeah.
I think that, and if it's not as good, at least understand or in a tools somewhere it will show why it's not as good. I mean, sometimes it's a trade-off that we just don't support certain ways of writing certain stuff. But it's good to know that that's all the reasons why these are different and not others minor stuff.
I'm gonna start. Okay, I have a bunch of things to do, but I guess we really do gotta merge assembly if we want AMD gems. Like we have to merge our own like lowering pipeline to assembly. I don't think there's much value in just having the agent like mess with the assembly code.
Agree. Yeah.
But yeah, okay. So I think that like LUM is probably too much, but LLM inference and asking the question, not just how much can it speed it up, but how many tokens did I spend? We want to reduce token spend. We have this like it's a velocity. Right? It's like tokens per token per second. Right? Like how many tokens do we spend to improve things by 10 tokens per second?
How do you measure that?
I have a budget of 200,000 tokens. I say I check out Tinygrad Master. I say speed up Quen.
Seconds per token.
I have 200,000 tokens of like GPT or something.
It's a very difficult problem.
Why? It's like what kernel bench is.
What's that?
Have you seen kernel bench?
Which one? There are just so many random benchmark now.
Kernel bench is like
Okay, maybe. I don't know. I feel that's too difficult to optimize for.
what do you mean? We already did it. Did you see the one that gets like 200 something tokens per second on Mac?
Yeah, that's fine.
Yeah.
I mean, having a budget and trying to optimize per that budget, I feel is the difficult.
Why? I mean, everyone always has a budget. It's just a question of what it is.
Okay, I don't know too much about this.
But yeah, I mean, does this seem like a reasonable direction to go? I agree that we have to wait that gems are blocked on assembly.
I think it's reasonable. Yeah.
Cool. Yeah, I want to get the Kimmy stuff merged too because I'd really like speeding up Kimmy has value.
Oh yes, Kim is unusable on the MI300, MI200s.
You think you can deal with getting that merged?
Mm-hmm.
Right. Yeah, Kimmy. I mean, because like speeding up Quen is like fun, but like nobody uses Quens. If you could speed up Kimmy, that's actually like usable.
Mhm.
Yeah. So let's get Kimmy merged. Let's speed that up, and then you know, then we get the real fun of having the thing speed itself up. Like using GPT, you know, 5.5 is great, but you know, we don't own GPT 5.5. Tinygrad can't speed itself up with GPT 5.5. Oh, did you fix the bank conflicts in CopyMatML?
There's a branch for it. It's fixed and it's a little faster. Like 80 teraflops to 90 teraflops.
Cool. Any reason not to merge it?
I'm still looking at it because like you don't always want to have zero bank conflicts. And there's like this tuning that you have to do. I almost think like I would let the LLM auto tune, because what can happen if you optimize too much for the bank conflicts, you'll end up having scattered LDS accesses, and you'll have more transactions for memory for the same amount. So
We instrument that too.
we can. It can do that. It just looks at the PMC counters and figures it out very fast.
Yeah, I mean, let's do that. Let's forgetting about ASM. You're right. We're not going to get state of the art kernels, but we can still improve AMD copy matml a lot. That's getting.
I almost think like it's an argument to the AMD copy matml that just like adjusts itself based on the shape of the gem and what your budget is. It's like Hyper-V.
No, I mean, I would just like write one thing that's like good. I wouldn't worry about making it too generic. But yeah, I mean, is there like I see this fix for the bank conflict? Like, I think it looks pretty good.
Mhm.
But LDS. Oh god, I can't read this. How much space are we wasting? What's like the percent overhead?
Percent overhead for this one? Oh, this
Yeah.
one's very tiny because you see it's fast. It's faster. Like when I tried to over optimize with higher block sizes, it actually got slower to have less bank conflicts. But this one like got to 0 and it's faster. This took like 5 minutes with GPT 5.5. I was kind of shocked. Oh, it's so fast. Yeah.
Cool. But yeah. Yeah, let's get Kimmy merged and let's start speeding up Kimmy.
Yeah. I think that's more reasonable than any assembly near term.
Right.
Yeah.
Yeah, no, and then when we get to ML Purple, we'll talk about 4 or 5. But
Can we also put this on benchmark? So whatever.
oh yeah. Can you add can you add copy matml to we have the H benchmark, right?
Our machines are very slow.
Oh
Probably
yeah.
want to remove some of the very old llama.
Agreed.
Up.
Why is Tiny are none of the Reds taking jobs?
I think one is running
Like
ML per.
One
And
should
the
be
other
taken
drop
jobs. I
from-
think the other ones just need tokens again.
You're the ones that need tokens? Oh, GitHub tokens?
Yeah.
Why did
Okay.
they lose their GitHub tokens? Where'd they go?
Let's fix this after the meeting.
Yeah, we'll fix that in a minute. Okay.
Next. I think next is your stuff. I don't know what that is.
Yeah, I don't know what that is. Okay. Okay. You want to remove D-type vac, right? So the first thing you realize about removing D-type vac is that like it's pretty clean, except for in one place. There's one place where we use D-type vac to mean something different, and that's in the indexes for images. So we use D-type vac to represent the XY pair in the index for images. So you're like, okay, first I need to remove that. But then you realize that you can't really remove that because the index in CodeGen is semantically different from the earlier index. You can't do 2D indexing in the indexing in CodeGen because there can be an optional gate added to the end of it. So then you ask, well, there really shouldn't be a gate on index ever. You want the gate to be on the load in the store. So I move the gate to the load in the store. Painfully, but that's done. And because there really shouldn't even be a load in a store, there should just be a store. Like store is the only operation that has side effects. So it makes sense that you just gate a store. Nothing else in Tinycorp has any side effects. So yeah, we now have gates on load and store. Then I start to work on removing, actually, so you can do the indexing on images as a 2D index. right? The image should just have the shape of the image, even probably including the 4. And then it's really a 3D index. It's the X, the Y, and then the range from 0 to 3. Or like a vconst from 0 to 3, which says that it's expanded. So yeah, that is where the image index should go. Then you start to try to do this, and lots of weird things just break. And you realize that like there's not really a clear separation right now between instruction selection and like generic rewrite transformations. So we have 2 that are basically generic rewrite transformations. There's the D-type decomposition. So the D-type decomposition is generic. Like the D-type decomposition is anything to do with instruction selection. We can actually do that in the beginning. And then there's not just the D-type decomposition, there's also the lowering from the weakends. And the lowering from the weakends is awful. Like so much
wrong.
It's yeah. So I want that to be gone, and then yeah. But then you realize that you don't just want to get rid of the lowering from the weekends. You actually want the entire the same way that we should make broadcasting implicit, we should make D-type promotion implicit. And I'm curious what your opinion is on that. Like if I do an int plus a long, should that be allowed? Or do I need the explicit cast?
I think it's fine.
To just do implicitly promote long.
This is the similar reason to the shape.
It's broadcasting, yeah. So we want to basically move like D-type promotion and broadcasting into ops, and not have to make them explicit, because this makes a whole lot of things a lot simpler. Like you're not in these like bad intermediate states, which is what so much of that weekend promoter does. Like 90% of it can be deleted once you have this. Yeah, you just need to occasionally look and be like, oh, I see. Okay, well, this one is going to overflow, so let me just add some casts, right? Because those have to be explicit casts. But so then I just get into all of this, and I just get frustrated because test won't pass, and I realize that most of the reason these tests start to fail is because we don't have a very clear separation between this like middle optimization chunk and instruction selection. So then I started working on making that explicit, and I'm working on a rewrite of spec so the diagram for Tinygrad to always think about is like, it's like an hourglass with like a thick rectangular middle. So we have all of these massive things on the front end of the hourglass, things like convolutions, things like mapmols, things like avionics op, right? And then that all gets funneled down into UOPS. And then we have all these transformations on UOPS that just do UOP to UOP transformations. And then at the end, we have the things that actually say, okay, you can use things like sub, you can use things like, you have to do your even the expands of like something like exp, right? The expand of something like exp actually is still completely in UOP language. So that's a transformation that can go anywhere. Same as these G-type ones, right? Like these are not instruction selection things, and they need to like be treated as such. They need to be treated as part of optimization, not as part of instruction selection. But then we do get to things that are instruction selection, like even maybe adding load. Load is kind of like, it's an instruction. It's not a it's not like the D-type transformation, right? The D-type transformation I can do a tensor. I can't add load in tensor. So that becomes the delineation marker. I played around with lean for a bit to be like, oh, can I like write like the UOPs in lean and improve things about them? But this turns out to be like useless. It doesn't help you. The problem isn't that we need to like prove things about UOPs. The problem is that we just need to be more careful about where we introduce certain UOPs and remove certain UOPs. So yeah, that's how I end up.
And don't, in the stack.py, don't just add stuff to the share and say it will be all fine. It's impossible to remove load.
No, I know. No. I'm doing it manually, very slowly, adding one rule at a time. And then like when I add a rule that's bad, I write a comment about how it needs to be removed. And I just think that it's going to be a long grind, but we have to go through and remove. I mean, now, I merged the spec into Tinygrad, so now we actually have spec. So like we have like a basic reference for like where things should go. And then yeah, there's a bunch of implementation details that are crap still, but like they're gonna go away. So yeah. You start out with like, oh, remove D-type vec, but then you realize that it's not removed. Like, sure, could I force it through and remove D-type vec? I could, but I'm not really sure what that would do. But yeah, D-type vec will eventually be removed, and then we're left with just a much tighter description of the whole language. And that's another like escape hatch that we don't need. In fact, D-type in general is a whole escape hatch we don't need. D-type should not live on UOPs. D-type should be implicit. The only UOPs that should change D-types are like buffer views, consts, and casts. There's source UOPs that initialize a D-type, and then there's cast.
Your buffer that has.
What if you have one of these things like a expanding multiply, where you have like two in 32s and you multiply them together and you get an 64 out?
I think that's not what we do.
Yeah, we don't, but this is something that hardware can do, right?
Yeah, then I would just put that as cast to N64 before the multiply.
Before the multiply.
I'll put it before, right?
Yeah.
Basically, there's only a very small set of UOP or ops that tells you what the D-type should be. The ones that initiate some kind of buffer or buffer-like, I don't know what's our name for that now, and explicitly cast into something else. And everything else can be inferred.
Yeah, no, and then there's some that will like, but then we can also always do this like once you get down to the instruction level. Once you're down to the instruction level, instructions can override D-types and stuff, right? Like, but the D-type override becomes explicit and not required on each thing, right? Like this UOP changes the D-type. It's just a different way of writing. Like all these production rules basically become recursive properties. I want to add one more recursive property too. I want to add address space as a recursive property. We have kept that. That's been on the D-type as well. Like we have this D-type pointer, which can tell you what address space it's in. And why is that in the D-type?
Yeah, what is that in the D-type?
Why is that in the D-type? I don't know.
There are enough of weird code that says for this UOP do things differently if it's a pointer.
Okay, the pointer needs to be.
Okay, great. I think we are on a good direction.
Yes.
And we can move on to your stuff.
Yeah. Yeah. So the big thing I did this week was making like AM and NV less dependent on the internet. So right now, assuming you have the right files in lib firmware, if you run with AM, you won't download anything. The one remaining thing is PMC. So if you run with PMC equals 1, then you still download stuff. And so we can autogen that as well. It's a YAML file, not a header. It's a little annoying, but I mean, depending on PyYAML at autogen time, seems like probably fine. Or we could do it with regex. That's what we do now.
At autogen time is fine. If you're including it, yeah. The requirements to re-autogen everything can include PyYAML and Clang and like, these like kind of tier 1 requirements that are like, that's not weird. Like,
Probably better than having the regex thing that we have right now.
oh yeah.
And I did some similar work for NV. So we look at lib firmware as well now, as opposed to downloading the like in data files from OpenGPU kernel modules. I was also looking at getting the register definitions as well, which are nice and organized compared to AMD's. So it should be a lot easier.
NVIDIA's.
Yeah, to autogen those.
So in terms of downloading stuff, is Kama happy now?
From what I understand, yeah, I think they need to ship a new Agnos with the lib firmware stuff. But
But they are going to do that, and they're happy with it.
yes, from what I understand, the next Agnos release will have this, and everything should work.
Yeah, we're not going to start including AMD's firmware blah blah blah.
Yeah, because that was part of the motivation to do this.
Yes, yeah.
Okay.
No, I mean, I'll bump Tinycrad in OpenPilot again today, and I did that last week and the week before, and there weren't any issues. So doing that. Yeah. So trying to clean up tests. We had that on the board with the goals for the timings for each test, but
Sorry.
yeah, right. Anyway, in general, it definitely needs to be faster. And yeah, I mean, on my Mac right now, it's a little bit slow, and then also definitely in CI, it takes like almost 15 minutes.
GitHub is just broken. Every time when we have a random crash, I'm like 85% sure it's just GitHub being broken.
Wait,
Yeah.
no way. Okay, so there.
Never breaks on my machine.
Yes,
It never breaks on our machine on the CI.
two basic types of crashes that we see in GitHub. There's the type where the GitHub internet sucks, and that's actually just like the GitHub internet sucks.
So GitHub virtual machine sucks.
The ones where like one of the LVM tasks will crash, this is not GitHub.
So my other hypothesis is we just at some point use too much RAM.
That's, I think, more like
But
yeah.
it shouldn't crash, and the fact that it crashed is like this virtual machine setup sucks, right?
No, I mean, I think that it's very possible that malloc is returning 0. Like malloc can return 0. People don't like remember this, but it can.
Well, we can check, right? You can check to see if what is it called? Like the setting in Linux is set so this malloc never returns 0.
Yeah, I think we should look into this. Right, my guess, my top guess for those random GitHub crashes is out of memory.
I think it is because I check lists. I check how many things we use per test and trying to put the heavy ones together and see if it triggers crash more likely.
But I mean, that's like the main difference between your local machine and our CI machines. Our CI machines have gigabytes and gigabytes of memory. Those don't really have any. But yeah,
So you can, if you are interested, are a few tests, especially the ones that test with real giga thingy that use on the memory because we keep the decoded model somewhere, the actual models reference that we compare. You can instrument these tests and like print how many meant to use. I think it's very close to some limits, and that might be why it's flaky and sometimes it crashes just because our the dash and auto like split. Or
we
something.
should also like use fault handler or something. Like when it crashes, we should be able to. It shouldn't just say segmentation fault. Like we can say why.
No, I think that's big. And I don't know. Sometimes maybe it's just timeout, and our timeout, the timeout we set is not very useful. Because I think now if it time out, it just crash.
Yeah, we should set up a timeout in
So-
PyTest probably.
This is yeah.
I think as part of the improving test in general, we're just looking to like the memory usage and the timeout crash.
But I'll say this about the GitHub runners. This is worth fixing. These are not like sometime being put in an adversarial environment is just stupid. But I generally think the GitHub adversarial environment is kind of good. It's like kind of good, like it forces you to think about these edge cases that you wouldn't otherwise think about. It's not that the computers are broken and randomly execute instruction wrong.
I think it's more of a sometimes you're just randomly being put on the crap machine that crashes more often.
No, I think you're put on the crap machine that has less gigs of RAM.
No, that's not true, right? These are all virtual runners, and they should set a boundary like fine, and that if you are within the allowed limit, it shouldn't crash.
Yeah, but
And I'm pretty sure we are within the allowed limit.
I don't think we are. I think that what happens is like there's so many different race conditions that can expose too. Like when you run it on your machine, you're not going to hit race conditions because your machine is
Yeah, it's a great machine.
you're the only one on it, right?
No, I load test that.
No, but even if you load test it, right? Like the GitHub,
Yeah, that's what I mean by if you don't do the virtualization fine and it does weird stuff, then maybe no, right? Anyway, we can improve all those. We all want tests to be more reliable and faster. So let's go that direction, and we can move on next to buffer JIT refactor.
So I've been working on HTTP2 this week. So I merged some runtime HTTP implementation to extra for now. So it's possible to run this on AMD with HEQ 2 equals 1. So yeah, it has all the pattern measures to load down to the HEQ command buffers, and then it just builds the C launcher with these patches. Yeah. So I think this week I'll work on the new graph and disks.
Looking at HCQ2 now, I mean, it still has a lot of these classes. You need these classes?
No, I mean, it actually doesn't need this. I mean, but for the program, it's actually I mean, like to make this work with Beam, yeah, but actually that's like also should be refactored.
I think we gotta, yeah, I think that it's worth, like, before you do the migration of all of these things to HCQ2, I think it's worth doing those refactors. Like, the basic ideas here are look correct. Like, okay, you're gonna like lower the command buffers, you're gonna resolve the actual, like, the refs. But yeah, I want those classes, like, gone. Have
Yeah.
HCQ compiled. We shouldn't have HCQ program. It should all be every
Yeah,
time.
so HQ
Yeah.
program, yeah, it should gun, yeah. The only difference, like in the order I would implement this.
Let's see this. Okay, and then ops AMD2 is like doing like is your AMD inner PM is basically like the running of the
Yeah, I mean,
is reasonable.
it's not in the best shape like the AMD ops 2, but yeah, it basically has some the pattern matcher to run.
I mean, I like that pattern reminds me of what you have in Realize now. I think that pattern's basically correct. But I
Yeah,
think
so yeah, so actually the idea, and not this PR, but before that, I had. So actually, this HCQ was implemented like it was like the extension of the Realize. So, and I didn't use this HCQ program class, but yeah, basically it was kind of hard to glue this with Beam and with other things and timings. But yeah, I'll do that. Just
I mean, we're eventually gonna get to a point, I think, after the three factor, like, we're just gonna want to increase our per second we can run. Once we have a good separation of like how to like batch a program and turn it into a time, it should kind of be like, that's a rewrite rule, right? Literally rewrite the program to a float.
yeah.
I mean, like, that might be too cute for now, but kind of like the basic thing that I imagine for Beam is that you generate like all these graphs, compile them all, and then there's some step that lowers the program to a float, adds in the float. Probably doesn't lower it, but it just says like, here's your canonical timing. Like, yeah, like as a rewrite rule, right? Imagine it just being in program spec, right? Like, imagine just adding to program spec the program timings.
Yeah.
Like an idea to kind of talk about like how, right? Because like you already added like Beam to program spec, and I think that's the right place for it. But like imagine also adding like the return value of Beam to program spec. Just like, yeah, I ran it 6 times and here are the timings.
Yeah. Yeah, I thought of something like that. I thought that like run realize could return timings and just use it inside Beam.
Instead of the function even like returning the timings, like it still returns a UOP. It's just like a rewritten UOP with the timings attached to it.
Yeah. Yeah, okay, yeah.
Oh, cool, yeah. Just to to keep in mind like what the North Star of all this stuff is too, is we want to get to the point where like the GPU driver is on a GPU. So that like one GPU can bring up another GPU.
Yeah, so yeah. I think it's already kind of possible. You just need to change CPU to AMD. It will render launcher for the AMD backend as a kernel.
You think that's possible in the HCQ2 stuff right now?
Yeah. I mean, it definitely works for Python, so you can kind of switch with these backends.
Cool. Yeah, good progress.
Llama?
We are submitted for MLPerf.
Left. It's like 3 hours and 7 minutes.
3 hours, 4 minutes? There are 7 minutes? Yeah, there are 7 minutes.
7, right?
37. So we're 33% worse than AMD.
I didn't check your branch. The one you put in the submission form is just pretty much master with
It's
very.
just master.
So everything is in master.
Yes.
You just add something on the. I'm not sure if the branch you added is also uploaded to GitHub. But previously, every time after I submit, I will push the branch there. So in case people want to check it just from the GitHub, they can see it.
Yeah, I can do that.
I think that's what I really doubt anyone reviewing our thing would really run it, but it's always good to just have some version on our public. Really didn't
Yeah,
run it.
that makes sense.
5B?
Sorry, you cut out?
B next?
Yeah, 405B next.
Maybe 70B first.
70B? I think the goal this week is to train 8B MP.
No?
I think that's
What?
it. And then if that happens, then I'll do 70B.
It works. Yeah, it used to work.
Yeah, so I mean,
Well, with all the custom
they
kernels,
still work with all the custom change here
yeah,
and there.
that's the main thing.
But yeah, no. I mean, what I want to see is in like maybe like 2 weeks, I want to see a converged 70B.
Yeah. And then I also want to start porting the custom kernels to UOPS.
Which ones?
A lot of them are the ones that don't. I don't know, I think most of them are fairly simple. None of them are that complex.
I mean,
I think in terms of priority, probably it's better to just focusing on GP because Lee's like translation truly simple and just like mechanical translate. I feel it's probably fine to wait a bit until we know what every one of those look like, especially for the 405B.
Yeah, I think we can also just take them out, right? I think that like I'm fine with like it's good that we got the time that we got, but like if we just don't do the custom kernels for now, it shouldn't be that much slower, right? We leave like flash attention and gem, but
Yeah, with just flash attention and gem is fine. Some of the custom kernels save memory too because we fuse more ops.
Yeah, but those are the parts that we really want to see if we can bake that into our scheduler or the parts that we determine.
yeah, no, I agree. I don't think that rewriting. I think we should probably just take them out and then like we need or add a comment about how like yeah you can like put this back in and save memory.
Okay.
Because all these I imagine would just work. I think very along with Koslim's work on making things more accessible to agents. You would imagine these GPT cloud code would just get better in a few months.
Yeah.
And the things we need to prepare now is kind of a translation task for what's before and what we want it to be look like, which we have here. And we have our current UOP structure, and we know kind of these custom kernel will be fast. We would use this for like mechanical rules. Even if it's not possible now, I would imagine it would get a lot easier a few months later. Having a comment make it easy to see like what we have now and what you have tried to be the best. Are we good enough? We don't really need to make a change.
Great. We should simplify, and we should just focus on getting the big ones to train and worrying less about the speed.
Right.
Yeah, I think also these things that are going to get you, you're like, oh yeah, you can do this like fusion and you can save memory. You can also just do this with gradient checkpointing. Use call and like change what we gradient checkpoint, and then the memory will all come back.
Yes.
It'll be so negligible.
I think a priority is to get 70B training and making sure we can run 4 or 5B.
Yes.
Because like the next deadline is the real deadline.
The next
and-
deadline. The deadline.
Yes.
Yeah.
Yes.
Do we know yet if it's going to be they're going to remove it?
I think we are going to remove it, but again, we are still in this round, right? So we would know better.
Right. No, I doubt it's going to be removed. AMD is for some reason sending us new computers.
Yeah, I thought they were sending us GPUs. From the meeting I had with them, it seemed like they were just sending us GPUs.
That's what you told me. That's what I thought. I don't know. It's just baffling to me that they're gonna like build some MI 300 boxes because like one GPU has a badly soldered voltage regulator or something.
I take that as a good thing.
Yeah.
So just making sure we will have the machine that's good enough for our next submission, and prioritize having our model trend with custom kernels.
We'll try to keep the 350 machines.
Okay. Issues, comma happy is comma happy.
The one thing that Comma did mention that would be nice to have is being able to cross compile. So be able to compile for the AMD, like the USB GPU without it plugged in. This would be a nice feature that they want to have. Can't do that. Like this is not something that we support. It's like something that we could definitely support, especially after HCQ2.
Yeah.
Worth keeping that in mind as a potential use case.
I've also been talking with Comma training their big foundation model. They're using there's nothing that they're doing that we're not already like dealing with in our llama trainer. It's amazing how much I feel in the last like 5 months we've just sort of learned about like train these things, how to do inference on the latest ones. The gap between us and the state of the art of LLMs is closing. Like it was think about like how many years, like think about when we were like training BERT, how many years old BERT was. Now it's like, yeah, like llama training is still old, but it's not the stuff that we're doing inference on is the absolute latest stuff. Like we have inference now on like Ian and Quen. Okay, there's like one little generation ahead, the DeepSeek V4 stuff, but like, okay, what, we're 6 months behind now compared to when we were like years behind.
Technically, it's also just out for 6 months, so you cannot be that behind.
Well, but that's what I'm saying, right? Like we're catching up to this,
Yeah. Okay.
which is cool. Yeah, I see the path for the first time to like replacing Commas Trainer.
I mean, they train.
They do. Come on.
Sounds good.
I see Commas here. Does Comma have any comments?
No, I do not have any comments. I'm also excited to use more TinyGrad. Need to get more people working on trying to port more parts of our stack to TinyGrad. I think
Hey.
some inference parts in the training stack can for sure be TinyGrad. The last thing we were discussing was replacing our Onyx runtime with TinyGrad.
Oh, the one that because Torch was magically like 2 times faster, so you use Torch.
Yes. Well, currently we use Torch and Onyx runtime, and for the speed critical stuff we use Torch. But if TinyGrad was the same speed based on Onyx graphs as Torch, this would be much preferable.
On NVIDIA, on AMD, we're the same speed.
I see. But currently TinyGrad's already faster than Onyx runtime, so we're hoping we can port Onyx runtime to TinyGrad, and then maybe sometime in the future we can port the PyTorch stuff.
Bar is low in Onyx runtime.
Exactly, so we can start there.
With Torch and Torch compiled, the bar is quite high.
Yeah,
That's quite good.
yeah, but I mean, it's really, really ugly, right? Like you need to save the code. Like it's kind of disgusting.
It's fast.
Yeah. Yeah, so we'll try to start soon with porting the Onyx runtime stuff, and then we'll if we have any complaints.
Go on, TJ, any comments on Kimmy?
Hello?
Hi.
I think Kimi is good to merge. It's a little slower now. And I just found our MD backend for the AQL package. We set the fence always to be the system.
You set the fans?
Yes. The fence scope system. And
Oh, yeah.
and it can be scope agents in some time. It have potential 10% speed up.
I think before we focus on the speed, let's focus on getting this merged. How much of your LLM shard support PR can you split into things that are like bug fixes versus things that are like new functionality? I see like a lot of things just being more precise about the device. You just do those things as a separate PR.
I think there have bugs. Maybe some clean up PR first.
Be great. Let's do a cleanup PR. Let's get that merged, and then I can really review the shard support stuff. There's another PR in there about all the device stuff that we have to clean up. But
For this meeting,
Flam was here for a minute. He got some thing that took agents a long time. Yeah.
great. Okay.
Yeah.
Okay, thank you everyone. See you next week. Bye bye.